Good morning. Hi, everybody. Okay, so I know there are not a lot of you, but probably they'll watch it later. I don't know. Anyhow, good morning to those of you who are here. And today we're talking about function notation. This is another one of those things that I feel like is really important to understand for the ACT. Um, we have taken notes on this before. It was at the very, very beginning of the year, though. So this will be somewhat review, a couple of new things, and yeah. Just as a reminder, you have um, what was it, J-2 homework due today. And I went through all of the problems with you as the lesson on Wednesday. So if you missed that, go watch that. It will help on your homework a lot. And yeah, that's due at 5 today. So, and if you still need help, I'll do a study session today at some point. Okay, function notation. Zooming in. First, function notation. Oops. There you go. Function notation just looks like this. It's this f of x thing that happens quite a bit with functions. So just as like a review here, this f part of the f of x, I am tired, thank you. Yeah, the f part of the f of x is like the function name. Oftentimes, maybe I should make my pen smaller so we can see it. Oftentimes they'll use F, G, and H. Don't ask me why they use those specific letters, but they often use those three letters to name functions. However, you could use any letter theoretically. And then this part in here is just the variable that we're using. It can also be what we're plugging in to the function. And then this last bit, I just made this function up. This is just an example function. So the f of x stands for a function, and it's essentially standing in place of it. And so we can use this notation, the f of x part of the notation, to stand in place of the entire function. And we can actually use it to do a lot of things. So when we're using it, let's see. When we use function notation, the most common thing that it's used for is to indicate what to plug into a function, what to plug in, and where to plug it in. So that's the first thing, plugging things in. In order to plug things in, I'm just going to make up an example function. So we have f of x is equal to x squared minus 2. And what you'll see is something like, what is f of 2? And this indicates that you are plugging in the number 2. So notice that we replaced x, like normally it's f of x, we replaced x with 2. And so this means plug in 2 to the function where x is. So we take, trying to decide what color to use. So we take our function, I'm gonna add a question mark. We take our function and we plug in 2 wherever there's an x. Hopefully this doesn't feel brand new here. So I just plugged into wherever there's an x, and then I just figure out what that number is. 2 squared minus 2. 2 squared is 4. Minus 2 is 2. So that makes 4 minus 2 is 2. So that means f of 2 equals 2. All we did was plug it in there. So just as another example, f of f of 4 would equal, hang on, I'm going to be more organized. The reason I look tired is because for some reason I stayed up super late last night and it was a mistake. Probably going to show. Okay. Also going to move this up a little bit so we don't get confused. Okay. Now we have f of 4 equals 4 squared minus 2. In this case, 4 squared is 16, minus 2 is 14. So f of 4 is 14. Really quickly, you can also do this with like letters if you want to replace a variable. I don't know why they would do this, but it could happen. I've seen it happen and I can't remember what the context was, but if it says something like, what is f of y instead of x? You do the same thing, except for you can't actually calculate that. You just replace the variable with y. You just change out the variable. So f of y would equal just y squared minus 2. You wouldn't have to do any calculations there because you can't. Yeah. So that's like a very important function. Very important. I don't have words today. Reason that function notation exists is because it can tell us what to plug in a language that's really concise and quick and really exact, which mathematicians enjoy. A second important reason that function notation exists is that we can use it to combine functions in different ways. I'm just going to make up some examples here. We're going to have two functions this time because we're combining things, so we need to. So I'm going to say f of x is x minus 4 and g of x, different function, so different name, equals x squared. And they can say things like, what is f of x plus g of x? All they're saying there is just add the two functions together. So in this, like, we're just replacing, let's do some creative highlighting here. So we're going to make this pink and this green. I hate pink and green together, but I'm going to make an exception. So notice that we can just, in that f of x plus g of x, we just have two functions here. We have the f of x function and the g of x. We're going to just take the other half of like what that function is and add those pieces together. So f of x plus g of x is just going to be x minus 4 plus x squared. This part having come from the f of x part, and this part having come from the g of x part. That's all it wants. One more example of that kind of thing. When we're subtracting functions, it's important to use parentheses because, actually I'm going to switch the direction here. We're going to do g of x minus f of x. When we're subtracting, it's important to use parentheses. In fact, if in doubt, always use parentheses because it's way better to have too many parentheses than too few. So we're going to say, highlighting again, g of x comes first, and then we're taking away f of x. So what I'm going to do is I'm going to do x squared minus parentheses x minus 4. There. And once it's out and you've seen what the parentheses are doing, I'm taking away that whole function. So the parentheses in front of the subtraction in front of the parentheses gets distributed into the parentheses. So it would end up being minus x and then plus 4. But same idea, right? It's just, we just have to be careful about subtracting a whole function, oops, from another function. Last thing we're gonna do today, well, not really. We have one more last thing to do after this, but function inception, I wonder if you've actually seen that movie now. Inception is a good movie. It's an old movie because I'm old, but remember how we talked about how it was about basically a guy goes into the dreams of other people, and there's like layers where you're like in a dream, and then in that dream somebody's sleeping and having another dream, so it's like dream in a dream in a dream. Anyway, not relevant except for the fact that you can do that with functions. You can put functions inside of other functions. And Inception is the best way I can put it because that movie, I always think of that movie before when I'm like doing this kind of thing. So again, I'm going to have two different functions. I need a f of x and a g of x plus 2 and x squared. Again, I'm going to do like some highlighting. I'm going to pick different colors. How about orange and I don't know, everything's too close. We'll do blue. G of x is going to be blue, f of x is going to be orange. Okay, so the way that you write a function inside of a function is that you put it, essentially you're doing the same plugging in thing, except for you're plugging in an entire function. So it will say something like, what is f of g of x? Which I know looks really intimidating, but notice that we have like f of something, and that something, hang on, oh, I'm not using highlighters, that's why. So we have f of something, that's the f function, and then g of x, I know. This is probably the one that gets everybody, honestly, because it's hard to think of putting a function inside of another function, especially when they have the same variables. It's confusing, so I get it. But just notice that we have like the outside portion is just f of something, and then the inside there is just the function g of x. So when we have f of something, like a function of something, we're plugging in whatever that is to the function. And in this case, it's x plus 2. So whatever it is that we're plugging in needs to go where the x goes. So I'm just going to leave like a box here, plus 2. Because we're plugging in, this is the f of x function, and we're plugging in something to this function because it's x plus 2, so we would normally replace the x with whatever we're plugging in. So we're going to just replace the x with, instead of having it be a number, we're replacing it with a function. So when it says f of g of x, we're plugging in the g of x function, which is x squared. So that could be a lot longer. You could be plugging in like 10x plus 5 minus 25y, or I don't know. But in this case, it's just x squared is the entire function. So we've plugged in, we've like stuck inside the f of x function, the g of x function. So we replaced in the f of x function, we replaced that variable with the entire function from g of x. So the kind of finished product here looks like x squared plus 2. And you can actually do it, so f of g of x, like plugging in g of x to f of x is different than plugging f of x into a g of x. It doesn't go both directions. It doesn't end up being the same both directions. So I'm going to do an example, the other direction example, where we are plugging in f of x to g of x. Again, I'm going to highlight creatively here. So g of x is this part, and we're plugging in f of x. So it's exactly the inversion of what we were doing before. And you'll notice that it will do different things. So instead of plugging something into f of x, we're plugging something into g of x. And that function, g of something, is just that something squared, because normally we would replace that x with whatever we're plugging in, like 2 or 10 or f of x. So I'm just going to put a box there so that I can fill it in with the function f of x. And speaking of which, I didn't give myself enough room, because that function is like x plus 2, and I need to be able to fit that in there. So what we're plugging in is f of x. And f of x equals x plus 2, so I'm just putting x plus 2 inside of the function g of x. So the finished product, and I will highlight that, but the finished product looks like f of g of f of x equals parentheses x plus 2 squared, because we replaced that x in g of x with the entire f of x function. Let's highlight. Okay, so f of x is this inside portion, and g of x is the outside portion. And we plugged in x plus 2 into that function. Okay. One other thing I wanted to talk about is the, okay, so there's a classification of a function that I don't know if we've done this before. Yeah, I don't know. Anyway, so there's a function, there's like a type of function called one-to-one. And it comes up on your homework, which is why I'm doing this. I was not sure if we had talked about this before, so we wanted to talk about it. This word, this weird like thing, one-to-one, is actually a label for kind of function. And so first, like, okay, so remember, I'm just gonna remind you really quickly that a function, for a bunch of like for something to be a function, it needs to pass the horizontal line test, right? Like you can't have like squiggly lines that cross over each other, because that would not be a function. Basically, there's more than one output for one input. So one-to-one, a one-to-one function is sort of the like an additional qualification. So one-to-one is going to be a function. It's already like a function. It already passes the horizontal or the vertical line test. I don't know if I said that wrong before. Vertical line test is what gives you a function. So maybe we'll write that. I'm sorry to make you erase if you've already written this, but I just want to make sure that that's clear. So a function, the label function, only applies if for every x value, there's only one y value. It also passes the vertical line test. And let's see. When I talk about functions, I usually also talk about how like basically like a vending machine, how if you push one button, if you push the button for Doritos, you don't want it to randomly, like most of the time, give you Doritos and then randomly give you like Skittles. That would be a broken vending machine. It would not be functioning, right? So in math, a function is if you input a value, you always get the same output value. It's always going to be input 2, get out 10, input 2, get out 10. Like you're never going to input 2 and get out 1. And the way that that sort of translates onto a graph, and I'll draw you an example of something that is a function and something that's not a function. So this is going to be our not a function. This is going to be our function. So not a function is something like this, where if you were to pass a vertical line across it, I'll get it red. If you pass this vertical line across the whole thing, it's like a moving line. It's like we're scanning the whole thing. Um, you end up hitting the graph twice at like most of the time, right? Anywhere you put that vertical line, it's going to cross the graph twice, which makes it not a function. Something that is a function, for example, is like a straight line or anything that passes the vertical line test, because anywhere you put this vertical line, it's only going to cross the graph once, which means that it's a function. For something to be one-to-one, it already needs to be a function. Yikes, one-to-one. For something to be one-to-one, it already needs to be a function. So I'm going to write that. Needs to be a function. It needs to pass those qualifications up above. It also needs to have, well, basically y values don't repeat. And again, I'll draw you. It's easier for me to see with a picture, and I bet it's the same for you. Instead of needing to pass the vertical line test, it already passed the vertical line test, actually. We already tested it. It's already a function. But it also, to be one-to-one, it also needs to pass the horizontal line test. And the official definition is that for every value of y, there's only one x. Okay, again, I'm going to do a couple like examples of things that are functions. I mean, things that are one-to-one and things that are not one-to-one. So this is like our not one-to-one. And this is one-to-one. A not one-to-one would be something like anything where you get the same y values if you plug in two different x values. So like, for example, on a parabola, like a normal parabola is a function. It's like it passes the horizontal line test because it never crosses anything twice. But if you pass a horizontal line test, did I say vertical before? I don't think I did. So parabolas pass the vertical line test, but not the horizontal line test because it passes these twice. Any function where you can plug in like say +1 and -1 and get out the same y value is not one-to-one because it doesn't pass the horizontal line test. Something that is one-to-one is like these kind of squiggly graphs that go this direction. So not only does it pass the vertical line test, but this kind of function also passes the horizontal line test. If you pass a horizontal line across that whole function, the only times it only ever touches the graph once. Yeah, so that does come up once on your homework, and I just wanted to explain it in case I haven't before I've lost my mind from being by myself. Yeah. Anyhow, that was all I had for you today. The homework has a lot of ACT questions on it, I think. Anyway, I was looking at it and several of the questions I was like, so if you need help, please join a study session, even if that's on Tuesday when you're working on it. I don't know, but please get help if you need it. And I was talking to somebody like yesterday about, he was like, yeah, I'm almost done with like 4 assignments, but I have like one more question that I couldn't figure out. Like if you're like stuck on one question, just skip it. Like it's not worth not getting points for it for like 9 years. I'm okay if you skip it. So just to put that word in. And anyway, happy Friday. I'm glad it's Friday. I'm gonna go on a hike today because it's sunny again. So enjoy your Friday and enjoy the weekend. And hopefully I'll see some of you on the study session that I'll start in a couple of minutes, probably at 11. And yeah, cool. See you guys. Have a good rest of your day and a good weekend.